to discuss what are the procedure for solving a circuit by using this method. The first procedure. First you find number of mass in a given circuit or a question circuit. Second point, after finding number of mass in a given circuit, you assign or assume loop current in each mass, either in clockwise or anti-clockwise direction. Third point, you apply or write Kirchhoff's voltage law for each mass. After writing Kirchhoff's voltage law, you have to find the circuit element. Suppose a circuit consists of n number of mass. Then when you write KVL equation, you get n number of KVL equation for n number of mass consisted by the circuit. So let us consider one simple example. I take one simple example. Having a single voltage source V. The resistances R1, R2, R3 and R4. In this circuit, question is to find mass equation. What is the procedure? First you find how many mass are there in the given circuit. If you see this circuit, it consists of two closed paths, which are the mass. This one and this one. Let this one is mass 1, this one is mass 2. Second point, you assign or assume loop current for each loop either in clockwise or anti-clockwise direction. I assume let clockwise direction of loop current. Let this one is I1, this one is I2. I1 is the current flowing through loop 1, I2 is the current flowing through loop 2. Next, third point, apply KVL for each mass and find KVL equation. So first I apply KVL for loop 1 and find the equation, mass equation. Step 1, I find KVL equation. KVL equation. See, mass 1 comprises of one voltage source, two resistors. These two resistors, here energy loss takes place. This battery is the supply one. What is the KVL equation? What is the Kirchhoff's voltage law? It states that the algebraic sum of potential difference to difference is V in this point. Then come to this point. Here the potential difference is current flowing through this branch into its resistance. So current flowing through this branch is I1 into R1 is the potential difference, as it is the energy loss. So I take a sign negative, I1 into R1. If you remember Kirchhoff's current law, we assume incoming current as positive and outgoing as negative. Similarly, here we assume supply polarity is positive and drop polarity is negative. But here you see that how the current flows through vacuum. If it is from negative to positive, if it is from negative to positive, raise in potential takes this and its polarity is positive, and if current flows through positive to negative, then fall in potential takes place and its polarity, the voltage polarity is negative. Then come to the potential difference across this point. As we write the KVL equation of this loop, we already find this potential difference, this potential difference. Now we find this potential difference. Here, the current flowing through this part, that is the R2, is the loop current of both I1 and I2, as it is the mutual resistance, or we may say that it is the common resistance for loop 1 and loop 2. So both loop current flows through R2. Okay. So you take the resultant of these two current. If these two current are of same direction, then resultant current through R2 is additive, otherwise it is subtractive. So check how these two current flows through R2. If you see, I1 is downward, I2 is upward. I1 and I2 are opposed to each other. So the resultant is I1 minus I2. You may have the question, why not ma'am we write it as I2 minus I1? As I write the KVL equation for loop 1, I assume its current is greater than the neighboring current. So I write here the potential difference across R2 is I1 minus I2 is equal to 0. You take it as equation number 1. Then you write KVL equation for mesh 2. You see, mesh 2, it doesn't consist of any source. It only consists of resistors where voltage drop takes place. So, here, sum of the voltage drop is equal to 0. In mesh 2, sum of the voltage drop is equal to 0. Which voltage drop? Across R3, across R2, and R4, and across R2. Again I say, across this point, R2, across R3, then across R4. Clear? So, R2, as voltage drop, I take the polarity minus. Current from is I2 minus I1, as I write KVL equation for loop 2. So it is I2 minus I1. Then across R3 only I2 current flow, and across R4 also I2 only flows. So it is R3 I2 minus R4 I2 is equal to 0. Question. take it as equation 3. And equation 2 became, if you reorder equation number 2, you get after reordering equation 1 and 2, you get equation 3 and 4. Here, if you compare this equation 3 and 4 with the base equation, in the matrix form is for 2 cross 2 matrix. As you see here, why I said 2 cross 2 matrix? Here you see, in this example circuit, you get 2 mesh equation with 2 unknown. Hence, you compare this equation 3 and 4 with 2 cross 2 matrix. I write the mesh equation for 2 cross 2 matrix. I take this one is equation 5, this one is equation 6. If you compare equation 3 and 4 with equation 5 and 6, you get a conclusion that this equation, it consists of, from this you get conclusion that the self resistance in each mesh, again I repeat, self resistance in each mesh, mutual resistance between each pair of mesh, and sum of voltage in each mesh. 3 points to get a conclusion. First, self resistance in each mesh. These two are the self resistance. Why? By comparing, I will explain. Then mutual resistance between loop 1 and 2 and 1. Okay. So if you compare this 4 equation 3, 4 with 5 and 6, you get if you compare 3 with 5, R11 equal to R1 plus R2 and R12 is minus R2. Similarly, if you compare equation 4 with equation 6, you get R21 is minus R2 and R22 is R2 plus R3 plus R4. This is the sum of the resistance in loop 1. R11, sum of the resistance in loop 1. R12 and 21, mutual resistance in between loop 1 and 2. This one is loop 2 and 1. Which one is minus R2. Then R22, it is the sum of the resistance in mesh 2. Okay. So, from this, after comparing these 4 equations, now here you are very clear that when these 2 mesh currents are in same direction, mutual resistances are positive, their polarity is positive, and the 2 mesh currents are opposite to each other, then the polarity of mutual resistance is negative. Clear? Again I repeat,